I built an AI agent. Now the issue was getting it to remember things. So let me show you how I did it. Don't worry about it. That's my theme music. That's my little intro music. So y'all don't even worry about that. All right. So this is Gravity Claw. This is anti gravity. I made my own open claw with anti gravity. If you don't know what those two things are, go figure out what those two things are. And I wouldn't even suggest you watch this video after. You got a lot to learn. But I made an AI agent, and essentially what this agent is, it's like Chat GPT if Chat GPT could send emails for you. It's like Gemini if Gemini could schedule appointments for you. It's an AI that has tools that can execute tasks autonomously without continually being prompted. Now, it's a lot of use case for an AI agent, but you need it to be able to remember who it is, what it does, how it's supposed to operate with things, who you are, and this needs to be done over multiple restarts, over multiple days and weeks and months and years, and it just needs to have this persistent memory in the same way a human does. So I created a system for that. Now we're gonna start with the most basic part of the system. Honestly, you know what? I probably shouldn't even scroll like right here. Let me just pop this back up, and I'll go get that, and I'll come back. So yeah, man, having an AI agent has been really cool. Honestly, I use it for a lot of different things. I think the use case is like the most talked about piece of AI agents is, because everybody's gonna have a different use case. Everybody works a different job, does different things, has different lifestyles. So it's just it's been all the YouTube videos that you see out about AI agents are all like super like, oh, this is what I used it for, and this is what I used it for, and you only find a couple that teach you how to set it up. You do find a couple that talk about things like this, like the memory and whatnot. But yeah, so it's actually a really cool thing. Today I worked on making sure that because I have things scheduled at certain times, so trying to make sure that those things are working properly. That was what I worked on. Mission control no longer exists. Okay, there we go. All right. So let me go ahead and show you. Ooh, that was loud. Let me go ahead and show you guys the first tier of this memory system. Boom. Oh my, don't make me have to actually type in this. I hate actually having to like type in code. All right. Sorry, y'all. Developer life. You actually gotta like write some of this stuff out. It's very annoying. But it's also flex. You know what I'm saying? Somebody actually watching you do this is like their mind is just like, what? You're so smart. All right, let me run. Dot. Oh, I can't even run that there. I just did some of that for no reason. Right. All right. So this is the first layer right here, and I wouldn't say they're in any like real specific like orders, but I do have like three. So it has my name, my favorite color, right in here. So if I were to query my agent, let's open up Telegram, tell your grandma. We're gonna bam. Let's open up my agent right here. And you see already. You know what I'm saying? But let's just ask it what's my name. You guys can't see that. I got you. Pow. We're just gonna enter on that. It's gonna tell me my name. All right, and I can also query it. What's my favorite color? Okay, well, while I'm here, I did just get an email that Ollama is now actually an official provider for OpenClaw. So, and yeah, as you guys can see, my favorite color is purple. But this is like fresh on the press type beat. So, bam. Can y'all see this? Why is it so hard to like show phones like on? All right, can't show it. What I can do is just pull it up on my email. All right, so Ollama is now an official provider for OpenClaw, meaning Ollama can now be selected directly through OpenClaw's onboarding. Moonshot Kimi K 2.5. This Ollama release of Ollama improves performance of cloud models and their reliability. So I'm gonna be honest, I may go back in because I did rip Ollama out of my system. I was having some trouble with it, but I may go back in and re-enable Ollama. I had Model Router and Ollama, but I may I don't know. I'm gonna figure it out because I know that I am going to be like taxed for Anthropic. And also they don't allow you to use OpenClaw, which is why I'm happy I'm not using OpenClaw. I don't know if it's just OpenClaw or if it's any agentic framework, but right now they're killing people over OpenClaw. Not killing literally, but I'm saying they're nerfing people's Anthropic accounts over OpenClaw use. I don't want to snitch on myself, so don't tell them that I've been using it in Gravity Claw. But hopefully they have no issue as long as it's just not OpenClaw, because OpenClaw was who tried to steal, or who they feel like tried to steal their IP. So they probably have a vendetta against OpenClaw. And then you got to think about it. OpenAI then acquired Peter Steinberger and essentially acquired OpenClaw. So it's kind of like, they kind of have incentive to like be kicking people off their platform for using OpenClaw specifically, but hopefully that's not consistent across the agent economy or the agent world in general. So okay, yeah, that was cool. Okay, so yeah, Olama, that's not even what I came for. I really was here for a tutorial, but if you aren't used to my videos by now, it's kind of like more of like a hangout style. Like I'll be doing whatever while vibe coding, so just get used to it. But I think that may be all I have for the moment. Oh wait, no, I'm lying. I got sidetracked. I'm tripping. I'm wilding. All right, so that was number one. That was layer number one of the memory thing. Layer number two is right here. So layer two is Pinecone. Pinecone is a vector, or they have vector embedding. Now we're gonna go ahead and see what that means. Pinecone is a fully managed cloud-native vector database specifically designed for high-performing AI and machine learning applications. It is optimized for storing, indexing, and searching through millions or even billions of high-dimensional vector embeddings, numerical representations of data like text, images, or audio to perform fast similarity searches. So pretty much in a simple explanation of this, because this is how like AI works. If you don't know the history of AI, it came from letter prediction models. So predict the next letter of the word. You will tell it if it's right or wrong. It's a reward system. Learns from that. Then we move to predicting the next word in a sentence, the next sentence in a phrase, the next phrase in a paragraph, and it just kept going from there. Now, the way that it was able to determine what words are what is that in the training process, there are numerical representations assigned to different concepts. So the concept of boy could have a numerical representation of pretty much any numerical representation depending on the equation that they did to get to that specific thing. Now, if you think about it in the terms of a graph, you got an X and a Y. Usually that's what we're used to, is X and a Y. Those are two different dimensions. Now, if you add a Z, right? And you've got your X and your Y going like that, but your Z is going like this, the grown-ups here no. But what I'm saying? Your Z is going like this, your X, your Y, but your Z is coming out like this. This is 3 dimensions. This is 2 dimensions. That's flat. This is 3 dimensions. Just poking out. Pause. Like, yo, chill. Now, if you have, what I'm saying, obviously, you got 4 dimensions and 5. And so essentially, there can be millions, even billions of dimensions. Now, these dimensions, there are different embeddings at different vector points in these dimensions. There's different points on this graph. Like if I go like this and I have like a curved graph on a 2-dimensional, you could pick a point on that graph, and that point on that graph would represent a specific thing. So let's say the graph was time versus technological growth. So one point on that graph might be where we were technologically in 1989. So that's a specific representation of our technological advancements in that year. That point on that graph. So whatever number that point on that graph occupies from 0 to whatever, that would represent that thing. So whenever you talk about that specific number, you always know that it's talking about 1988, where we were technologically. So, if you can kind of understand that, that's what these vector embeddings are. Now, Pinecone is widely used to power long-term memory for AI models through several key applications. Semantic search, finding information based on meaning and intent rather than just keyword matches. Now, that's a big part of the memory system, because excuse me, because when I talk to my agent, when it responds to me, it doesn't just look and say, oh, well, you said the word blue, so I'm going to go look for the word blue. It looks and says, okay, well, you said the word blue. That is a reference to color. Color is a reference to a thing. That thing is so essentially it's associating the meaning of what I'm trying to say and going and pulling from that meaning rather than just keywords in my sentence that I spoke to it. Now that's super, super powerful because it has the idea of concepts. It gives the AI the idea of concepts, like what a concept is. It can understand it and it can remember it long term. Now, RAG, retrievable augmented generation, it's a lot better for space. It's a lot better for token usage, for cost, because it gives it the ability to go and retrieve only what you asked it for and generate its response based on only that, not having to, being able to actually neglect the rest of the information that was fed into the context previously. So that's a big one. That's honestly a very widespread technique that's been really used a lot in AI recently. Recommendation engines. So boop, 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 chat. All right, so these two are not that. Well, this right here is what we're using it for, but these two things right here are what powers my memory system. So boop, 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 documentation, free account, Pinecone, SDK, Python. All right, cool. So you guys got Pinecone, so let's take a look at it. Now inside of my Gravity Claw memory, we've got 2,624 records. The region is, if Amazon goes down, I go down. We're using a multilingual model, and this is the host right here. Now we have 3 different namespaces: knowledge, conversations, and default. So let's go ahead and let's look at knowledge. Let's see what's in here. Knowledge. Attorney Lana is right there. So these are greetings mirrored back from user input, causing confusion. So this right here is just like all the different memories of different moments in time, in different interactions with me and this agent. And I can actually pull up, like, let's say I pull up my name, right? Boom, Berkeley. So anything that had to do with Berkeley in the knowledge graph. Okay, let's see. Time zone. So it's just understanding who I am. Okay, a person. Remember this fact that the user's name is Berkeley. Their communication style. They have a communication style. So this is all, I didn't have to go do this. This all was created just from me having these conversations with my AI agent that I'm just having while we're doing the setup, and it's just pulling this data and this information and getting the concept of what it is and understanding what it is, not just keywords. So it's like, okay, Berkeley owns this profile. You see what I'm saying? Like he actually owns this profile. He has a direct communication style. You know what I'm saying? This is the, so they have the different IDs for each memory. His time zone is Eastern, you know what I'm saying? This is one way that people have spelled his name, so this is just, and that's just in knowledge. Okay. So essentially, yeah, this is the second layer of the memory thing. Gravity Claw has capabilities, so this is a second layer. Oh, I can actually pull more of these 20. Yeah, it's gonna pull the top 20. Okay, cool. So all of these memories stored right here inside of Pinecone. Now the third layer that I do have is Supabase. Supabase. Okay, so now we're inside of Supabase. I have different tables here. Now it's not super robust, but you can actually just get the gist. Here is the timestamp of when this information was updated and created, or when it was created and when it was updated. Let's keep going that way. Okay. So we've got things in here like agent has access to storing memories. Agent has access to sending emails. Agent has access to searching the web. Agent has access to recalling memories, reading emails, notebook LM, listing memories, deleting memories. You know what I'm saying? So this is all of the information that needs to be known by this agent right here inside of these tables as well. So, oh shoot, agent metrics just started working recently. So this is all the information about the agent. And as you can see, I use Claude 4-6 for pretty much everything. I've got my latency. I've got the cost right here, what it's costing me. And this is where my daily or my weekly report of my weekly cost is coming from. All of that's right there when this was created. So as you can see, all of these timestamps were today because I just completed this table today. So now that is completely done. It's robust. So that is my, what was this, a third layer, third memory layer. Now I do have a fourth tier. One second. Okay, so every Monday at 4 a.m., the agent runs what I call the evolution pulse. It pulls 200 messages from the past week, reads through all of them, and asks itself, what patterns do I see? Is this person asking for shorter responses? Are there tools that I'm using that I'm not using that I should be? Am I missing something? Then it writes those insights directly into its own core memory as permanent facts. So essentially at 4 a.m. every Monday, it checks out the last 200 messages from the past week, checks out what patterns it sees, checks out what things it should learn from. So this is like a self-evolution engine where this agent is like, okay, how can I be better? You know what I'm saying? So every week the agent is saying, how can I be better? So it writes those insights directly into its core memory as permanent facts. You know what I'm saying? It literally rewrites itself based on experience. I didn't train it. I didn't fine tune a model. I just scheduled it to do this. This is what AI agents have the ability to do. This is why AI agents are the future. So we're gonna continue. Okay, so another thing that I've scheduled. Thank God. Another thing that I've scheduled is at 2 a.m. every night. Actually, it automatically cleans out messages older than 30 days. And it sucks them out of the database to reclaim disk space. The reason I do that is because I don't want the database to be too big. I don't want to be paying too much. Yes, I do want this thing to have memory, but I don't want that memory to be running my pockets. So we're going to clean out messages older than 30 days. And that's just how I have it set up. You don't, because I'm not really yet using my agent for super heavy, like things that it needs to like really keep in mind. Now, had you been doing this for enterprise, a company, a business, this would not really be necessary. It would be something that, like, I mean, if they have the money to pay for the space, then you just go ahead and pay for it. And yeah, but I'm not trying to spend that money. So I've put some reins on it, and I just kind of let it manage its own memory footprint. So, I mean, if you want to be real, I probably spent like to create this agent. I probably spent more than I can really even count in terms of like, I don't know what I spent because a lot of this stuff had like free tiers, and I essentially had I got to use that to set it up, and that payment is coming on the back end. So that's why I have a job scheduled to let me know what I'm spending every week. So that is so I think that is about three three of the three of the systems that it writes memory to. Okay. All right. So now I do have it set up. I'm not sure. I don't think it actually has pushed backup yet, but I do have backups scheduled to of the whole entire code base to Google Drive. Now that's going to include the tables where the memories were stored, so I can always go and pull that from there. Um, Last but not least, we have, and I want to show you guys, but I don't want to like necessarily jump all the way into like code. You know, it's gonna be a little crazy, like just looking at it. Even this right here just looks weird, but essentially, and then you can see right here, my little cute little agent over here. So essentially, yeah, I'm sorry, I'm also trying to remember where I was at. Yeah. So essentially, these are the Last but not least, yeah, I didn't want to show you guys code. Um, Last but not least, we have like actual like documents that memories are getting written into. So this is just a like super locked down memory system where we have like a bunch of different fallbacks, and we have a bunch of different things that can be synthesized to have some really robust memory. And so that's what I did. So as you can see, so you could set up your super base, you could set up your Pinecone, get these things mapped out so that you can ensure that your agent is remembering things correctly. So that's all I have for now. Thank you guys for engaging, and I will catch you on the next time.